Hello guys and welcome back to another class of our course about the complete introduction to data science. So in today's class we are going to talk about machine learning. So in the past class we talked about what is it in general, how it works, and basically all the basics of this. And in this class we are going to talk about the different machine learning algorithms. So we're not gonna go into practice of those algorithms. We are going to cover all the theoretical part. So basically I'm gonna talk about each of those, each of the most important machine learning algorithms, how they work, and simply give you a brief little introduction to each of those algorithms. Once again, my goal is not that you guys become professional in all this, but simply that you guys understand what is it, how each of those algorithms works, and basically all that you can do with machine learning and Python as well. So let's not wait anymore and let's jump right into it. All right. So basically the first machine learning algorithm that we are going to talk about will be linear regression. And this one is pretty simple to understand. So basically the formula is y equal to ax plus b. So basically, as you can see on the graph right here. So what exactly is linear regression in machine learning? It's simply a supervised machine learning algorithm where the prediction output is continuous and has a, we can say a concrete slope. Basically, the slope is pretty much the same since it's y equals ax plus b. So basically, an example of machine learning regression could be the graph right here. So we can say, for example, that right here we have the price paid for example, let's say a plate. So let's say in a restaurant, you guys are buying something, and this would be the price paid for your dish, so for what you have ate. And this would be the amount of tip that you guys have left. So basically, as you can see, this would be our test. So the system will be able to tell us that the more someone buys, the more the plate is expensive, the more the person will leave a tip. So the more the tip will be high. So basically, as you can see, and there would be right here, we will have a in the middle, we'll have our slope that will be right there. So as you can see, it's drawing right here. So basically, this would be like the average or the mean. Basically, it's in the middle of all the points. Some linear regressions are better than others. So in some of them you will have points everywhere. In some of them the points are very condensed in one place. Those are more representative. So basically a slope like this would be more representative than if we have points everywhere and that is one slope in the average. It's not really representative. So this is for linear regression. All right, the second type of algorithms that we are going to talk about will be the logistical regression. And it's not like linear regression. Basically, this is logistic regression. It comes from statistics like the linear regression, but it's not an algorithm for regression problems. In other words, problems that require the prediction of a continuous outcome. So basically, it's not for this. So logistical regression is really a method that is used for binary classifications. In other words, 1 or 0. So it will give you a discrete binary outcome between 0 and 1. So as I said. So if we want to think about something, so basically we can have, as an example, we can, for example, say, do you like to eat outside? So basically asking someone if he likes to eat outside, yes or no, could be a logistical regression, and 0 in this case, yes, let's say yes in this case will be 0, and no in this case would be 1. So basically it will look something like this. So as you can see, all will have 0 right here, and we'll have 1s right here. And after that, we'll have an average, and this would be our outcome. So basically the majority of people like to eat outside if it's closer to 1, because the 1 is yes and 0 is no. So basically this is another type of regression that we can use in machine learning. But once again, this one is really important, like the first one. And the difference between linear and logistic is that logistic is really between 0 and 1. So this is more of a binary, the outcome that you will have will be a discrete binary outcome, not like the linear regression. Alright, so the third algorithm that we are going to talk about in this class is pretty simple. It's called the decision tree. So I think we already talked about this type of algorithm at the beginning of the course, so basically about decision trees and other stuff related to this. So basically, what exactly is a decision tree? So basically, decision trees, well, in general, are constructed via an algorithm approach that identifies ways to split a data set based on different conditions. So basically, we will have different conditions or different variables that we will need to take and put into consideration to be able to create our decision tree. So it's once again one of the most used and practical methods because it's really based on how we as human beings solve our problems. So basically, let's take an example. So the example right here that we have. So once again, this is a decision tree that will help us know what animal we are talking about. So basically, the first question that we are going to ask is, does he has feathers? If yes, can he fly? If no, has he fins? If he can fly, that's an hawk. If he can fly, that's a penguin. If he has fins, well, that's a dolphin. If not, that's a bear. Once again, this is really basic. Decision trees are almost everywhere. So basically, when you guys go, for example, to buy food, let's say you guys are going to buy a pizza. So basically, you will find decision trees when you will buy your pizza. So the process of buying a pizza could be a decision tree. So as you can see, this is really used everywhere. So not only buying a pizza, so we do it without even thinking about it. And implementing this inside of a machine or inside of a system can be something that could be really useful in all aspects of our life, and well, in general, simply having this inside of a system can be really useful and make the system way more optimized and performant. All right, another type of algorithm that we are going to talk about today will be the support vector machine, which is one really interesting algorithm. So basically, this is a supervised machine learning algo that can be used for classification or regression. But this algorithm is mostly used for classification purposes. So what does this mean? It's pretty simple. So support vector machine algorithm is able to generalize between two classes that are different if the set of labeled data is provided in the training set of the algo. So basically, if we provide enough data in the training set of the algo. So basically, the goal of this algorithm, or the support vector machine algorithm, will be to find a hyperplane in an n-dimensional space, where n is the number of features. So basically, we have features right here. And in the end, to be able to separate the two classes of data points. So basically, we have the two classes right here. And there is a multitude of possibilities of hyperplane that can be chosen. Basically, it sounds a little bit complicated, and you guys maybe don't see where exactly can be applied in real life. So let me just give you two examples. So let's say, for example, you want to create a facial expression classification model. So let's say this model will say the person is sad, happy, I don't know, the person is surprised, the person is shocked, or whatever. Well, basically, you will use a support vector machine algorithm to be able to build this. You can build this with this type of algorithm. Or another thing that will be, for example, text classification. So basically, you will compare a text written by a human being and a text written by a machine, or simply being able to translate a text written by someone to a computer, so basically to Word, for example. A good way to do that will be by using the support vector machine that will be able, with training of course, will be able to spot this type of text and simply transform it. So basically, there are plenty of tasks that the SVM algorithm model, the SVM model or the SVM algorithm can realize, and it can be really useful for machine learning purposes. All right, another algorithm that we are going to talk about today will be the naive Bayes. So basically, this is another algorithm that is really used in machine learning. So what exactly is naive Bayes? So this is a classification technique that is based on Bayes' theorem. So basically, to be able to work with it, you need to understand the Bayes' theorem. So it will assume that there is an independence among predictors. So naive Bayes assume that the presence of a particular feature in a class is not related to the presence of any other feature. So this is basically the main reason why it's called naive. It will take some features and basically it will use those features to be able to say, for example, okay, this is, I don't know, a pizza, for example. So let me just give you a quick example. So let's say something is round, weighs 500 grams and has different colors on it. So basically the theorem will say, oh well, this algorithm will say, okay, this is a pizza. So basically all the attributes, all that I said, have the attributes of a pizza, for example. So even if it's not necessarily making sense, so it could be, for example, a cake. It could be, for example, I don't know, any other thing that is round with some colors on it. So basically, this is the main reason why it's called naive. But once again, it could be really useful in classification and as well as to understand some other things. So basically, it's a one of machine learning models, and basically, if it's here, it's because it does a great job. So basically, how the naive Bayes works. So just to give you a small introduction to how it works, you not necessarily need to understand it 100%. So basically, you will start with calculating the calculation of all prior probabilities for a given class label. Then you will calculate all conditional probabilities with each attribute for each class. Then you will multiply some classes conditional probabilities. You'll multiply prior probabilities with the step tree probabilities. And finally, you will understand what class belongs to the given input set step, which in other words is the class that is with the higher probabilities. So you can have an example right here. All right, the next type of algorithm that we are going to talk about in this class would be the KNN, or the key nearest neighbor. So basically this algo is pretty simple to understand. So what exactly is this machine learning algorithm? So the key nearest neighbor algorithm is a type of supervised machine learning algorithm. So basically it can be used for regression predictive problems as well as for classification problems, but it's mainly used for classification predictive problems. So basically it's mainly used for this, but it can be used for both of them. So it could be used for classification as well as regression problems, but it's mainly used in classification. So the KNN algorithm has no specialized training phases and is using all the data for training while classification. So this is why it's really known as a lazy algorithm. So basically lazy learning algorithm, sorry. So this is one of the main reasons of why. The KNN doesn't assume anything about underlying data. That is why it's also considered a non-parametric learning algorithm. So basically, if there is two things that we can say about the KNN algorithm, is that first of all, it's a lazy learning algorithm, and finally, it's a no-parametric learning algorithm. So it can be used in many places in real life. So this is one example. So basically it's loans. Well, we have variables. So we have the variable loan, we have the variable age here, we have the variable non-default and default. So basically if the person have paid for its loan, yes or no. And basically it will use the distance between this point right here or any other point and the neighbors of this point. So basically the neighbors of this point, the closest neighbors will be this one, this point, and this point. And we are able to come to certain conclusions with this algorithm at the end. All right, another type of algorithm that we are going to talk about today will be the k-means algorithm, which is a well-known unsupervised learning algorithm that is used with machine learning. So basically, what exactly is the k-means algorithm? So it's pretty simple. As I said, it's an unsupervised learning algorithm that is used to solve clustering problems. So basically, this algo is uses a very simple yet powerful procedure to classify data through a certain number of clusters called K. So basically, K is a cluster. So the way it works, at first, we find the number of clusters and we assume where is the center of these clusters. So basically, we don't know where exactly is the center, so we make an assumption at first. So basically, that's the first thing we are doing when we identify them. Then we can take any object or the first K object as initial center. So basically, to be able to find the center, well, not to find, but to assume a certain center, this is how we will do it. And then the k-means algorithm will do the first, well, what it will do at first, it will determine the central coordinates. Then it will find the distance of each object to the center, and finally group all the objects based on the minimal distance. Sorry. So if we, usually looks something like this. So as you can see here, all the objects are grouped together. And to be able to understand a little bit more, let's talk about some real life examples. So basically, this machine learning algorithm could be used in plenty of ways. So some of the examples in which we can use it in real life can be, for example, document classification. So basically, we can classify different documents in different places, for example. So this could be a really interesting way to use this algorithm. Another thing, for example, could be customer segmentation. So basically dividing customers into different, types of customers. For example, customers that spend a lot, customers that use, I don't know, credit cards, customers that use debit cards, customers that pay cash, customers that comes once a week. So basically you can really segmentate your consumers. And another way, for example, in insurance fraud. So basically finding anomalies into, insurance contracts, for example, or people who are trying to fraud insurances. So basically there are plenty of ways that you can fraud insurances. So basically people who fraud insurances, it's possible to be able to make a detection of those frauds by using the k-means algorithm. All right, so the last algorithm that we are going to talk about in this class would be the random forest algorithm, which is once again another really powerful algorithm that is used in machine learning. So for those of you who don't remember, we talked a little bit at the beginning of this class about decision trees, and this is exactly, it's the same concept. So it's a concept of decision tree, just made bigger. So let me explain. So basically, random forest is a supervised machine learning algorithm that is used for classification and regression. So it can be used for both, but it's mostly used for classification problems. This algorithm works with decision trees, and there is trees in the algorithm. Well, the more there are trees in the algorithm, the more the forest will be robust. So in other words, here, for example, we have 4 trees. So it's more powerful than if we have 3 trees, but not more powerful if we have 5. So how exactly it works? Basically, you have decisions that are made in each tree. So basically, decisions are made in each tree, and it has to have the same outcome. So basically, each tree needs to have a certain outcome. So basically, choosing between A, B, or C. And basically, each tree will choose based on different, mapping. Will choose a different outcome. So basically, the more trees you have that choose a certain outcome, well, the more this outcome will be robust or strong, and the more there are chances that this outcome is the best outcome that you can have based on the random forest. In difference that if we only work with one decision tree, we only will know what is the best decision based on one decision tree. But with a random forest, we are able to know what is the best decision based on many trees that will each of them will map different scenarios and different situations. And at the end, this will be a way better way to find out the best answer to a problem. So instead of using only one decision tree, using a complete random forest. So if we want to think about it in a certain way, so basically this is just a decision tree that is upgraded. So we can see it this way. So basically it's more than one decision tree, and it's more than one decision. So this will simply confirm our answer that we have in one tree. All right, so I hope you guys right now understood all the different types of algorithms that exist in machine learning. So those are just the examples of the most used and once again the most simple. So once again, I'm not expecting you guys to become a professional, so this is just a brief introduction. I can spend hours talking just about each of those algorithms with all the mathematical and statistical aspect of each of them. So I tried to be as straight to the point as possible. So right now, guys, you have a complete idea of different algorithms that exist in machine learning. So that's it for this class, guys, and see you all in our next class.